the body. There are two ways it grows. One is called interstitial bone growth, and the other one is appositional bone growth. So the other one, interstitial. And please write interstitial with a capital I, so that interstitial bone growth. So you know that interstitial bone growth is bone growth that way. It's the growth in length. You go arrow up and down. That's how we grow in our height. You follow? So this type of bone growth, there's an ending to it. There's an expiration date, right? We can't keep growing forever like that. Once we hit puberty or the growth plates are closed, we're done with this interstitial growth. So you know how this happens, right? Ossification, the blast makes all of that, okay? So, by the way, here, you should be able to identify here. What do you see? What are the structures I see here? This is compact bone. This is spongy bone. Look at when, before I get to that, the other type of growth is called appositional. And you see P to P, they're side by side. The side by side, remember, that's the growth in width. This. So it's either that way or that way. So if you remember that way, interstitial with the arrow pointing up and down, that's how I try to remember. The other one must be the growth in width, appositional. Okay? I was going to say something about that.
About the split.
This one right here, right? This bone, look at when bone is formed. I'm going to go look at this one again, this picture of the baby. What you need to remember, I'm just going to look at, sorry, I changed my mind. Over here, this ossification, look at, you see, it says endo or intra. It's infiltrating inside. So you see, it's replacing it inside, but outside of the bone, it's covered. All around the bone is covered. If you eat your chicken, you eat it to the bone, you see that there's that membranous layer that covers the bone, the diaphysis of the bone. So that's what the outer covering is called periosteum. So you see, the bone is covered all around. All around. Over here, the covering is called periosteum, that membrane. And then on each end, you see, not all of it is replaced by bone. There is that cartilage that remains. You call that articular cartilage. What is this? It's nothing but hyaline cartilage. Is there a function to your articular cartilage?
It allows it to move.
Yes. And prevent, it's pain-free movement, right?
Usually.
The ground substance, you know of glucosamine, right? People take that. That really is the main ground substance of your cartilage. And so as we get old, we have less and less of that glucosamine. Some people start taking glucosamine supplements. Or you just make sure you're adequately hydrated. Take your vitamin C. You're sure to maintain your ground substance there. So there you go. Bone is protected all around. It has a wrapper. That's why you call it endochondral, intramembranous. There's a layer that protects it. You don't see the bone. It's covered inside the body. Okay? And so under this periosteum, I will have forever my osteogenic, my osteoblast, and my osteoclast. And in lining the medullary cavity, that's where I will also find my osteogenic, osteoblast, and osteoclast. Right here, in the compact bone, or in the spongy bone, that's where I'll find the osteocyte. They're already trapped. But out here is where I'll find the blast, the clast, and the osteogenic cell. And that's why I can still keep making bone when I exercise. Does it make sense? Okay? What's trapped here? So, when you're looking at your bone slide, what cell do you see? Only the osteocyte. Only the osteocyte. So look at this bone because of the fact that I have the clast, right? The osteoclast, it's still present, you see? I can tell whether the slide or a scan belongs to an old individual, hopefully, or a young individual, or osteoporosis or not healthy individual and a healthy individual. So the osteocytes, look at, they're very nicely packed in their lamella. You should be able to identify the 3 types of lamella. What do you think? What do you mean by concentric? Can you differentiate between concentric and circumference? Where do you think you will find circumference?
The outer edges.
Yes, very good. So this out, you see that outer lamella, the thin lamella all around. That is my circumferential lamella all around right here, outer. Circumference. And then each and every cell, you see how they have like a bullet? So that's what you call, they're wrapped around in concentric lamella. Concentric, circumference, all around the bone. So this is circumferential, that's concentric lamella. There are some lamella here, you see, if you look closely, there will be some lamella. Look at this. There's lamella here where there's no more blood supply. You see that? No more blood supply. You see? This one. You call that interstitial lamella. This one, all around concentric. This one, this one circumferential. This one concentric. This one interstitial lamella. In the lab exam, I used to point to the different lamella. So what do you think? This is how you want it to be, right? You want it to be nice concentric lamella. But every time our calcium level is down because of that clast, the clast will start eating on the matrix to release the calcium. So you end up with interstitial lamella. So this is remnant of previously nice looking concentric lamella. So you can tell the health of the individual. They have more interstitial than this. You know that they were compromised as far as calcium is concerned. They have to draw from their 401k, which is this one. You think? What you think? Okay? So you know that the circumference, concentric, and then interstitial is just in between. Interstitial, in between. The more calcium deficient we are, the more interstitial lamella we will have. And look at, between, do you see? Between this one and this one healthier. This one, no more blood supply, right? Okay? Okay. So we know how bone is formed initially. We know the sex hormones. What other factors affect bone growth? So, of course, hereditary, right? If you have short parents,
Right.
it's in your genes that you'll be short also. So we know that one. How about nutrition? We know now nutrition, the importance of nutrition. Like what? You're going to tell your parents, your parents, water, they need to drink their water. What else do they need? They need protein.
Vitamin C.
Yes, vitamin C. C for collagen. Always C, collagen. C, vitamin C, good for skin, good for your bones. Vitamin C is just all around, isn't it? Right? What? Vitamin D also, right? For calcium. Calcium with vitamin. You cannot make bone without calcium, right? Calcium with vitamin D. Your vitamin B12 and vitamin K. There's many other proteins that make up bone. There's osteopontin, there's osteonectin. You don't need to know those, but those vitamins help. Isn't your B vitamin, isn't that your metabolism vitamins? Isn't that your metabolism? When you're growing, isn't your metabolism up? You need to you need to have a higher metabolism so your bones will grow. That's why children and older people, children have a higher metabolism, they say, than older people because they're still growing. Does it make sense? Okay? So, hormones. We studied some hormones. Oh no, we didn't study here. We have growth hormone. Does it make sense? Growth hormones. For kids, when you're growing, your growth hormone helps you grow. Which part of you? Your bones. Growth hormone is released in spurts. And it's released, there's peak levels of growth hormone when you're napping during the day. I don't know why. For some reason, daytime naps releases or produces spurts of growth hormone. And we take advantage of that. That's why you tell your children to go take a nap, right? So then you can go sit down and update your Facebook, your profile. Right? I'm now single, whatever you want. Okay, so growth hormone. What do you think? How about this? Thyroid hormone. Isn't thyroid your metabolism hormone? So when you're growing, you need normal levels of thyroid. That's why people, babies who are hypothyroid, they're also dwarfs.
They're also what?
They're dwarfs, but you call them cretin. So hypothyroid children are called cretins. And people or children with deficiency of growth hormones are called dwarfs. But they're both the same, they're short. So when a patient is short, you go send them to the endocrinologist, they monitor, they check for the levels of growth hormone or thyroid hormone. They figure out which of the two is deficient. But it's very easy. You look at the top. In cretins, it's usually sticking out, and usually they're retarded because this is metabolism. That's just growth hormone. Okay? What other hormones? We talked about our sex hormones, right? Estrogen, testosterone. And they come into play more so during puberty. So you see why females, when we hit growth spurt, it seems we're growing taller or quicker than males. Because estrogen, it's like a nag, right? It's they just keep growing right away. Whereas testosterone is more laid back.
That makes so much sense.
You are way out now.
We can jump into the parking lot.
How about exercise? Right? What kind of exercise?
Weight bearing.
Yes, weight bearing. If you work in the orthopedic ward, you walk around, you see some patients when they have a fracture, in addition to being in a cast, you see them, there's a weight on the leg is up and then there's a weight that's hanging because stress, which is weight-bearing exercise. Walking is weight-bearing, right? So weight-bearing exercise stresses your bone. It actually stresses the osteoblast. When my husband stresses me, I start eating. But with this one, when exercise stresses the bone, it stresses actually the blast. And what does blast do? Yes, it makes bone.
Is that
So
why
that's
astronauts lose bone mass?
Yes, very good. Very good. There's no resistance. Okay? I remember that was one of the questions in my lecture test. Very good. Okay? So do you see why how exercise, what bone cell it stresses? Your osteoblast. In addition, what did you say? What does bone store? What is stored in
Minerals.
bone? Yes, what mineral?
Calcium.
Calcium. So in the test, I always asked, What are the two hormones important for calcium homeostasis? I told you, it is beyond our control. It's automatic. Bone stores calcium. And the purpose of that is so that moment by moment, the blood calcium level is normal. Doesn't matter what you do. Whether you're drinking soda, that's all you drink all your life. I had a student, that's all she drank. She said she hates water. That's all she drank. It doesn't matter. Even if you drink just that one, it's beyond your control. The hormones will make sure you have normal levels in your blood. So I need for you to know these two hormones, parathyroid hormone, and you write this with capital T like this, hopefully. You don't need to remember this long hormone. If you want to, that's okay. But the parathyroid hormone with the letter T like this, and you put an arrow like that. So that you remember that the job of parathyroid hormone is to increase the calcium level in the blood. This is the one that corrects calcium deficiency in the blood. Okay? So when the calcium level in the blood is down, so that calcium deficient blood is going to go to my parathyroid glands. And then they respond by releasing parathyroid hormone. This one goes to bone to release the calcium in the bone. Which one do you think? Which of the bone cells is it targeting?
The osteoclast.
The clast. The osteoclast. You see? So when the calcium ion in the blood is below normal, you see? The parathyroid responds by releasing this parathyroid hormone. So it goes to the bone to tell the class to eat. You see, it's eating the bone. See, that's why we end up with osteoporosis. At the expense, it's always at the expense of your bone. Doesn't matter. Because you cannot afford to have calcium levels to be off in the blood. You can die from calcium deficiency. Your heart will just stop contracting. So, you cannot. Thankfully, it's beyond our control. Immediately, this parathyroid hormone acts. How about when we are good to ourselves and we eat our yogurt, anything that's rich in calcium? Then we have calcitonin that's released by your thyroid gland. What will this do? It will grab the calcium and deposit it in bones. So will it tell your osteoclast to work? No, it will inhibit it. In the meantime, the blast keeps depositing bone. Again, in the test, I will ask what are the two hormones that participate in calcium homeostasis. The correct answer is parathyroid and calcitonin, and you should know when they work. You see, you have these hormones. That's why it's beyond your control. You don't have to do anything. All you need to do is sit pretty. No matter how much soda you drink, calcium is still normal. Why? You didn't do anything. It's the hormones. You can't stop them. So you end up with osteoporosis if you don't pay attention to your diet. Okay? So, is bone a living tissue? Yes. What happens if you fracture? It will repair. Your test will have different fractures. You match it, the lecture test. Okay? My favorites. Always green stick, comminuted, impacted, POTS, and Colles fracture. Green stick. Green like the green stick of the twig of the tree, right? When a tree is young, it's hard to break it because there's a green part to it. It's not completely bone, right? Right? It must be, this is in children only. They're still growing. So green stick fracture is a fracture where only one, see, it's not completely broken because this part of the bone is still soft. must only be found in children.
Is the green stick the one that they find in like child abuse cases where kids' arms have been wrenched
Sometimes.
and twisted?
Yeah.
That twisty?
How about your comminuted fracture? When you say comminuted, you see a fracture that has been splintered into many pieces. Comminuted. I try to remember a community of things. So, comminuted. Splintered into many pieces. When you say impacted, some students write compact. That's okay. You push, one end is pushed to the other. Impacted fracture. So the impact was so strong that one was pushed inside. You can write impact, you can write compact if you, but the correct answer is really impact. But sometimes I feel bad, I just accept compact. Okay? Then POTS, fracture. POTS is always affecting your fibula. This is common in old people. And then Colles fracture is fracture of your radius.
What was that one?
POTS, fibula. Fibula. And then Colles fracture is fracture of the radius. Carpal, Colles for carpal. It's not the carpals, but it's, at least I remember where it is.
Right.
Okay?
Is that the one they break, like falling?
Yes, that's right. Very good.
Because you catch yourself with your hands?
Yes. So how do you repair your fracture? See, this is what happens when you have a boo-boo. You have a boo-boo, it gets replaced with, first you have your scar. You see your collagen, first it becomes cartilage and then ossification happens again. But it's very important, because it's a dynamic tissue, they put you on a cast. It's very important to follow. If it says you have to keep it there for 6 weeks, it has to be for 6 weeks. Otherwise, it will heal, it will, but the shape will become different. See? Why? It's a living tissue. So there are your bones, and again, you're going to have your bone in the... By the way, I think I forgot to tell you, bone also stores, there are two types of compounds that bone stores. One is calcium, which is inorganic. The other one is fat, right? The bone marrow. My mother likes to make, it's called nilaga. It's a beef, the bone, and we make it into soup, and I like to eat the fat inside, the marrow.
Sounds good.
And that's fat. In the test, I'm going to ask you, bone stores what organic compound? The answer is fat. If I ask you, bone stores what inorganic compound? The answer is calcium. I just want to know if you remember the difference between organic and inorganic. Okay? So now you see this one, and it's not hard. That's hyaline cartilage. Those are your chondrocytes. They just become replaced by bone. There's also already collagen here, right? So the bone cells just assemble themselves. So look at the difference between normal bone, and this is osteoporosis, which is getting to be more and more common in young people. Okay? And we're going to study the bones of the skeleton on Wednesday. The things that I want you to remember about the individual bones. We stop here. You use the rest of the time to look at your microscopes.
Our lecture is only going to be over 6. It won't touch